notes today. Let's start with arc length. Arc length. How long is a piece of the circle there? The arc. So we're going to start here. How long is arc HK? How long is arc HK? We're going to write the formula now underneath this problem, and then we're going to go to the back of your packet where you have all the formulas you need to know. All right. Anybody want to show off arc length formula? This was unit 10 2 units ago. Not expecting to remember, but anybody remember any semblance? Let's go. And what do you have?
2 pi r.
Which is I was using circumference. I use pi d, but yes, you can use 2 pi r. I use pi d, and then what do I have to multiply it by?
The arc measure.
Perfect. Arc measure, which is in degrees, over 360 times its circumference. Okay, once you have that down, please go to the back of this packet where you have all the formulas you still need to know and fill that in for arc length, whatever number that is. So please transfer that in. Make sure it's arc length and not the sector one. All right, let's fill this. Go back to number 1. Let's fill this in for me now. What's the arc measure in degrees? What is the arc measure of HK? Here we go. Will? 9 degrees. If anybody's wondering, how do you know they're the same? That's a central angle, right? If these are two radii, AK and AH, that's a central angle. Central angle is always equal to its arc measure. 360 times pi. Now we're using diameter, so hopefully you guys aren't falling in the small trap here of using 3,954. You're using the diameter and doubling that. All these small little traps, right? And now we're using 7,908. And we're rounding to the nearest tenth of a mile. Make sure we're all good with the rounding here. When you're ready, please. When you're ready. Aditi, what do you have when you're ready?
1 second.
Yep. 9 over 360 times pi, 7,908, rounded to the nearest tenth of a mile.
I got like 621. Like 0.09.
That's 100th.
0.1, yeah.
0.1, yep. All right, everybody good? Done? All right, let's use this formula again, but for solving for a different part of it. They're going to run counterclockwise from A to S. Everyone good? Counterclockwise. And if you didn't know what counterclockwise is, there's another piece here that it would tell you. Find the degree measure of the minor arc. All right, how many degrees are in this minor arc? And they tell us the distance is 247. Okay, so we know how long A to S is going counterclockwise. All right, where's that 247 going to come into play here? Where can I put that into the formula here? Kira, where can I put that into the formula? That is my arc length. Yes, good. That's 247. I'm looking for the measure of that arc, so that's where my X is going. Over 360 times, don't fall into the trap. We're not putting $1.50, right? We're putting pi times 300. Unless you're using 2 pi r instead of pi d, then you can put in 150. Do both sides have pi in there? Both sides of the equal sign, do they have pies? No, so you cannot just cross it out. The 247 would need a pi to be able to cancel them. So you guys need to figure out, what am I going to get rid of first? The 360, the pi, or the 300? You have to get rid of all three eventually. All right, so you guys decide where you want to go. I don't want to tell you where to go. You could get rid of the 300 and pi in one step too. Divide both sides by 300 pi. You can do that easily in your calculator. And we're going nearest degree when you have your final answer. When we're ready here, John.
94.
94 degrees. Up. Just for, we could talk full credit here, because I know some of you hacks here can just type that into your equations and it'll come up with the correct answer. Bare minimum for full credit, you need to at least show this. All right, what numbers you're substituting into the formula. And then you can go right to the answer like I did, and that would be full credit. But you cannot go right to the answer 94 degrees, because we don't know if you know what you're doing or just have good eyesight. You catch my drift. Okay? You just have good eyesight with the person to your left or to your right. So you do need to show what you substitute in. All good? All right, couple more with arc. Now we're going to go to a different formula. We were just on arc length. Now we're going to go to area of a sector. Okay, area of a sector. Starts off the same way as arc length. That's why we're doing both today. Starts out with the measure of the arc over 360. But we do not multiply it by the circumference because we're not on the circle. We're in the circle now. So what do I want to find after I find the measure over 360? I don't want to find the circumference. If we go in the circle, we want to find area, which would be what formula? Pi r squared. There we go. Pi r squared. So once you have that down under number 3, yes, go back to the formula sheet and let's roll. And also, too, you can knock off number 7, right? While we're here. Area of a circle and area of a sector. We can just knock off 7 and 8. And heck, we can knock off 9 while we're here, because we just did circumference for the arc length. So look at us here. 7, 8, 9, 11. And we're going to knock off another one by the end of the day here. Back to number 3. We're told the area is 12 pi. We're told the area is 12 pi. What's angle AOC? All right, so substitute in the 12 pi for the area. Now, for measure of the arc. Everyone agrees the measure of the arc is the same as angle AOC. Central angle is always equal to its arc. So if you find the measure of arc AC, you have found angle AOC, because they're always equivalent. Central angle always equals to its arc. Times pi 6 squared. Now you'll notice, what do we have on both sides? Everyone with pi's on both sides? So you can now, unlike the last problem, we can cancel them out. And now we got to solve for x. Whatever you do first. Get rid of the 36, get rid of the 360. Type it into equations. That's always a good, useful thing to do. Good luck next year. And take your time, but John again, when you're ready.
120.
120 degrees. Yep. Anything from you guys? One more before we go circles, equations. All right, BOD. What's the area of BOD in terms of pi? Just separate this right now. And we were told that the arcs are congruent, AC and BOD. That's good to know because if the arcs are congruent, so are in this problem in particular, if my two arcs are congruent, let's see what else is congruent. The angles. You got a better name for angles? What type of angles? Thank you. Central angles are congruent. So now you can figure out, when you go find, you can figure out what is the measure of arc DB. All of them add up to 180, those three, and you already got 20, and the other two are congruent. What is the measure of one of those central angles so I can plug it in here? What's the measure of one of those central angles? Kira, when you have it? 80, good job. So I'll do 80 over 360 times pi. I don't want to use 12. I'll use 6 squared. Pi r squared. Bless you, bless you. In terms of pi, what are we looking at for the area of this sector? In terms of pi, Ayla? 8 pi. All right, there you go. Little formulas, area of a sector and length of an arc. All good? Questions? We are going to keep it in the circle family now and go to equations of circles. First thing, let's write the equation down, and then we can transfer it to our formula sheet. Here was the equation of a circle. X minus h all squared plus y minus k all squared equals r squared. H and k will have number values. Anybody remember from this unit what h and k represent? That's the... Oh boy. Oh my God. Why don't we just start yelling out like parallelogram, slope. Center of the circle. I'm sure we were just going to start yelling out. Yep. Hypotenuse. Yep. We would have got there sooner or later. Hopefully we have more success on the next value. The R value. Hey, there we go. That's the radius length. Look at us. But just make sure it's got to be squared before you plug it into the formula. All right, so you can have that. Make sure you get it into your formula sheet before we start this problem. All right. So now the question is, let's review. This is not the circle equation I've given you, but we need to transform it into the circle equation. Which one's equivalent? That's what we're asking for. Which one's equivalent up here? Do we remember the name of the process we need?
Complete the square.
Completing the square. Yes, here it goes, kids. Here it goes. Completing the square. First step, get your x's and y's grouped together, and the single number, the constant, goes to the other side. So reorganize this right now. So I have x squared along with negative 2x. And then I have y squared with 6y. And I subtract that 3 over to the other side. So that's the first step. Reorganize this bad boy. Step 2, find the new c values on x and y. Because right now, each of them have an a and a b. They need a c now. They need a c value. Always positive. Anybody remember the process to get the c value?
Square it.
Take your b value, which is negative 2, cut it in half, and square it. So do that in your head there. Cut negative 2 in half, you get negative 1. Square it, you get 1, positive 1. So there's my new c value on the x's. And now take 6 for the y's and do the same thing. Cut it in half and square it. End up with 9, yep. Here's the one thing you got to remember. It's unbalanced when you do that. So you do have to rebalance it by adding the c values to the right, both of them. Now you can remember my hack or factor. It's up to you. All right, each of these need to be factored. They should be the same number. Two numbers that multiply to 1 but add to negative 2. Negative 1 and negative 1, but if you write that
Negative 1 squared.
the fancy way, it's x minus 1 squared.
Well, what was the half?
We'll talk about in a second. Two numbers that multiply to 9 but add to 6. 3 and 3. The hack was just take your b value and divide by 2. Yeah, that's how you can get the numbers inside. Take your b value and divide by 2. And then what am I looking at here? 7? Okay. So that should match one of our choices then. X minus 1 squared plus y plus 3. Choice 2. Completing the square. Yes, Violet.
Wouldn't it be 7 squared?
7. No. Why? No. The radius would be radical. Because remember, this is the equation. So the radius would be the square root of 7. If I plug it back in, that's when I square it. Okay, yep. And if I ask for the center on this one, it would be positive 1, negative 3 for the center. All right, all good there? All right, now you look at number 6. And this is where I'm going to throw up. You look at number 6. What's the center and the radius? Well, we're going to have to complete the square, right? Everyone agrees? All right, well, I'm going to save you some time because we already did. Your calculator can tell you what the center and the radius is. All right, and of course, I never showed this to you because being in an honors class, I'm not going to show you right away that your calculator couldn't do it, but desperate times call for desperate measures. All right, I want to make this very clear, but before I show you how your calculator can do this. If this is not a multiple choice question, you have to show completing the square. You just put down the answer because you got it from your calculator and it's not, maybe it's a part 2 question. You're only going to get a point out of however many it's worth. Okay, you got to still show work. So yes, you still need to know how to complete the square. If it's multiple choice, we don't need to show any work. I don't even know how you got it. Everyone ready to learn how your calculator can do it? This disgusts me. Go to Grapher, put in that equation, just like you would. It's the same thing we do to find the slope and y-intercept for a line. It's just for a circle now. X squared. And you don't even need it reorganized. Just type in the original one. Alpha y squared plus 6y equals 7. And when you hit enter, your calculator is going to give you this great knowledge that it's going to be a circle. You guys remember how the hack of how to get the slope and y-intercept? Same steps. Go over to the dots and go over to details. This is disgusting. All of you, disgusted. They give you the radius. And if you can't handle a point together, it tells you what the x coordinate of the center is and the y coordinate if you can't handle them together. All right? So there it is, kids. That's how you can use your calculator to find what the center and the radius of a circle is. Disgusting. Disgusting. Why do we have times 6 times y?
I don't know.
Yeah, me neither. So that's probably why. All right, there you go, kids. Use it on the multiple choice if you'd like. But forewarning, you can't do this on part 2. You got to complete the square. You can use it to check, right? You can use it to check. All right, everyone, all right with that life hack right there. Congratulations. All right, one more here. One more. -4, 2 is point A. 4, -4 is point B. What's the equation of this circle? That's a diameter, too. That's a diameter. Hate to break it to you. Calc ain't helping you here. Won't produce the equation for you. Go back to the equation. What are the two things I need? Center and radius. Let's start with the center. If this is the diameter, where's the center going to be located? In the middle, aka the midpoint. New formula. Anybody remember? Come on, we've been using it every single darn unit. Gage, come on, make me proud here.
X1 plus X2 divided by 2. And then do the same with Y.
Darn right. Good man right there. There it is. There's your midpoint formula. Make sure it goes, we're filling up this formula sheet in the back pretty quick, huh? There's formula number 2. When you're ready, come back to number 7 and find the midpoint of the diameter. We're on a new schedule there. Oh, plenty of time still together. My luck. Can I have the center of this bad boy? Center here. Scott, what do you have for center when you have it?
0, -1.
0, -1. Yep. So there's the center. You guys also chimed in. You need the radius length. How's that happening? 0, -1 right there. There's my center. How's the radius happening? It can happen a bunch of different ways. Sophie, one way.
Like x minus h squared minus y minus k squared plus r.
So you want to plug in 0 and -1 in for h and k? And then what about x and y? Because I still need the radius, right?
Yeah.
Okay. All right. Still need the radius length to plug in. How else can I get it? Kira?
Couldn't you make a triangle with it and then find the lengths of that by going down and then doing part of that?
I could. Okay. I've been hearing people chime in distance. Yep. You could do distance. All right. You could do distance. You could do the distance of the whole diameter and cut it in half. You could do the distance just from A to the center or center to B. Or here's what Kira just said. Hey, let's make a right triangle out of it. 1, 2, 3. 1, 2, 3, 4. And let's have a little fun doing Pythag. Multiple ways. Multiple ways of doing this. Figure out what's the best way for you. What is the length of the radius here when you have it? Length of the radius, Theo, when you have it? 5, good. All right, we have everything we need now except for the answer, the equation. All right, here's your H, here's your K, here's your R value. We have everything we need. So let me know what's going in the first parenthesis here. Whoa, wow. Wow, that was so great. Sophie, what's going to go in the first one here? X
minus 0.
Squared plus, what about in the second one?
Y plus 1.
And then what about over here?
5 squared.
Also known as 25. If also too, remember, because it's x minus 0, this is also good to go. Okay, without the parenthesis, but both would be accepted. How many hours do you have to take this? 3. When can you leave? 2. All right, we got a lot of time on our hands. If you want to check to see if this is correct, graph it, go to the table, and guess what 2 points should be on the table? Both A and B should be on your table. Okay, so if you want to check it, go back, graph it, go to the table, and make sure points A and B are on your table. All right? Okay. I'm only asking for 4 tonight. Okay, so let's get it going with those 4. We're here. What?
If we put in our final equation, what we should get?
No. If you type this into Grapher right now and go to the table of values, right? You guys got a table of values?
Oh, yeah.
No, that doesn't work.
Those 2 points, A and B, should be on there.
It doesn't, it says no valid function.
Why is that?
It says any circle.
They won't give you a table of values, huh?
How do you express there's a
Degree, why would degree know?
No, it just always happens in case you forget.
Why did you?
Would you do
Wait,
it?
why can't it just always happen?
So like the what, the third
Doesn't
time?
matter.
Huh?
Also, when you gave you
For your MC?
Huh.
teach,
Oh, yeah.
don't you do
To the
this?
same day?
That's it.
Different.
It's probably because, yeah, there's multiple values for, I get it.
Yeah.
I get it. I get it.
Is that like multiple?
Because when you have X has some X values have some 2 Y values, so that's why. Yep. But you can you can substitute it in, -4 in for X and 2 in for Y, and it should equal to 25.